Hello, and welcome back to Break, the Fallthrough after show. Although I guess this episode is not really as much an after show as it is like a before show. So it's just Matt and me today, just the two of us. And we were going to record an episode with Mitchell Hashimoto today, but we had some scheduling conflicts, so we didn't get to record that episode. So we're going to have to ship something else. There's some other episode that we have magicked up, either from the backlog or some recording we do between now and when we ship this that you will have just listened to, or hopefully just listened to. Sorry, we can't talk about that episode. So instead, we're going to be talking about some other fun random stuff. Probably talk a little bit about what we want to talk with Mitchell about. And there's some fun news in the Oxide world that we can chat about as well with their recent Series B and the future of Oxide now that it has even more money to go do fun stuff with. So yeah, but before we get to that, Matt, how are you doing today?
Great. I'm glad to be here. I'm waiting for this heat wave to end, and I'm like you, busy.
Yeah, no, this heat is just terrible. I do not like this. I do not like these 90 plus degree days. Really, it's the 90 plus degrees and the humidity.
I know.
You just walk outside and you're like drinking the air. You're like, I don't like this world upgrade. Can we
sucks.
roll this patch back? This is not fun.
It's not fun.
Yeah, air conditioners working overtime for sure. So yeah, what should we talk about first? Maybe we can talk a little bit about the episode that we want to do with Mitchell.
Yeah. I don't want to do the episode itself, but we can talk about like the idea and the premise there.
Yeah, I mean we can't do the episode without him. So
of course, no, we need him. He's our favorite Zig programmer.
This is true.
That's what I have relegated him to. Okay, not the HashiCorp founder. No, he's my favorite Zig programmer now. No,
not the HashiCorp founder, not the pilot, not the overall great guy. Yeah. He's our favorite Zig programmer. Yeah.
Yep. I mean, listen, you got to do what you got to do, right?
Yeah, not the creator of our now beloved terminal emulator that just puts all the other terminal emulators to shame. Well, not all of them, right? There's still Kitty and some others, but Ghosty's definitely hitting the charts at the top there. But yeah, we wanted to do an episode with Mitchell about libxev and event loops in general, and of course talking about Zig. But I think like the idea of event loops, libuv, libxev, these types of things is a topic that doesn't get talked about a whole lot, especially when you're talking about concurrency, because that comes up a lot, especially since we are Go programmers, so we're used to concurrency and Go routines and doing all the concurrency using that method or doing concurrency with those tools. But for everybody else that doesn't have Go routines, they're either stuck with threads or they can use things like event loops. And I guess like the high level what event loop is it's what it sounds like. There's a loop, basically a for loop, and then it is kind of automatically scheduled, and you give it events that you want to either have run or scheduled, or like triggers that you want to be running in the future, things like that. And it just kind of spins around really fast, and then it schedules and it decides like, hey, like what's the thing that I want to execute next? So, and it will decide, right? It'll be like, oh, well, I have these 5 things I need to run. Oh, this thing has a high priority. I'll run this thing first, and then run this thing next, and then run this thing next. And so it's a very easy, I would say, way to do concurrency. I think the place where it's mostly used is in the JavaScript world, right? The Node.js, but also in the browser. It's just one big event loop. Well, it's kind of a big event loop and some smaller event loops. The browser is also very complicated with how its event loop works.
Yeah.
But that's all based on, or at least the Node.js version of it. I don't really know if the version in the browser is also based on libuv, but the version in the Node.js is based on libuv, which is this, basically the go-to library thus far if you want to do event loopy things. And Mitchell has built basically a version of libuv in Zig and called it libxev. And so that's the main thing that we want to talk with him about, and also dig into like how does an event loop actually work, because it turns out that operating systems have support for event loops kind of built into them. So you can do things like network read and writes, and with some operating systems you can do file system read and writes. So any of that stuff that might usually block, you can make it so that it doesn't block, right? So if you want to do a write to a network socket, you can be like, oh, do this write for me. And then the event loop handle's doing it, and it gives you a response back once it's been completed. And the same thing with file reads and file writes and stuff like that.
Yeah, no, good introduction. I am really excited to talk to Mitchell about this. I want to understand the architecture of it, the pain points, why. I mean, I kind of know why, right? Zig doesn't have anything to do this async IO. For me, though, I was reading this, asynchronous programming in Rust book. I'm holding it up to the camera. It's the Pact book, Asynchronous Programming in Rust. And they talk all about the kernel primitives that are available in the various different kernels, right? You have epoll, IOU ring, KQ, whatever Windows's version is. I actually don't know what Windows uses under the hood. I don't remember. But all of the operating system kernels have primitives for doing asynchronous IO, or at least to understand and work with async IO, right? So you can write your own library on top of it. So they give you sort of signals, I guess, signaling and mechanisms to use. And from what I understand about libxev is it uses these primitives to be a cross-platform async event loop.
Right. Yeah.
And when you dive deep enough into this rabbit hole, you start to realize that basically all of the asynchronous runtimes or concepts that we have in these different languages, like Go has Go routines, right? So it's basically like a green thread, like application level thread. Rust also has its async runtime. It's kind of in the same model in a sense. They have their version of green threads in a sense,
right.
Not exactly. I'm papering over obviously a lot. And then you have the core OS level threads that you can have access to if you want to do that level of async.
Right.
But the commonality between all of that stuff is that they have to be built on some async IO mechanism. And usually that's libuv, libxev, or
right.
epoll itself, right? Directly on epoll itself. So yeah, I'm excited to talk to Mitchell about all this stuff.
Yeah, I think it's going to be, and just talk more about Zig as well. Because I think we both are we want to do more Zig. And then we're both oh, we have so much other programming we want to do. So be able to talk more about Zig. Be really fun because I think it's also still continuing to blow up in the world. I think people are still using it for more and more things, which is cool. I feel like it really does fit that little niche spot between Go and Rust. It's a nice little third member of that family of languages that are all people think they're pitted against each other, but they actually work very what's the word I'm looking for? They work in they're not at odds with each other at the end of the day.
Yeah.
Right. I was gonna say homogenous, but that's not the right word. No.
I know what you're saying. I don't know the word either, but I get what you're trying to say.
The word just slips out of your brain.
Yeah.
You're no. No. Harmonious. That's the
harmonious.
Word
There you go.
Yeah.
That's better.
Living in harmony. Yeah.
Yep. You're totally right. Go has its home, Rust has its home, Zig has its home, and I think Zig is one of those in the world of any sort of hobby or any sort of thing, there's the enthusiasts, and when they see something, they're oh, this thing too, because you wouldn't have picked this thing if you weren't an enthusiast. I think Zig is that thing. Zig's the language that you pick where you're you know what, you actually like programming. You know what I mean? You're I see you. You have that fine taste in wine, right? I see you. And that's what interests me about Zig, honestly. And it's low enough level where you can do some really nice things, but it's high enough level where it doesn't feel C assembly essentially. And I think that's really attractive, and I want to spend more time doing it. I am going to the Zig New York City meetup on Tuesday the 5th, I think that is. Yeah. August 5th. So yeah, hopefully I'll see some fellow New Yorkers there.
Yeah. Zig meetup. Maybe I should go to that. I don't know what I'm doing Tuesday night. Figure that out.
Hey, I'm just trying to spread my wings a little bit and see what else is out there, because I'm I don't really want to go to another Go meetup or another Go that I want to just branch out a little bit. Not that I hate Go. Please, I don't need DMs telling me.
People be oh, you hate Go now.
Yeah, I don't need the DMs.
No, we like Go. We will be at GopherCon.
Yes.
In a few weeks. It's kind of crazy that GopherCon's in a few weeks.
Yeah, I know. Everything's wild. We're basically in August.
Yeah, I know, that's also crazy. I'm how is it August? yeah, the time thing where it's like, how is it August, but how is it still 2025, right? At this, you're like, it feels like it's been 6 years this year, and it's really been 6 months. Well, I guess 8 months now, but well, it's been 6 months that we've been living in a very particular version of this world. So
yes, but no, I'm excited for everything. The conversations should be good. I have a much better understanding now reading this book, talking to my colleagues of these things. And I think the conversation with Mitchell will really solidify a lot of these concepts and understanding, and really just want to get into the whole, because we as developers, we just use these things. We never create them. We have an understanding of what they are, what problem they solve. But, Mitchell actually created this thing, and so does other people, for their respective async libraries and their languages. And it's like, I just want to dive into that world, because I'm probably never going to write my own one that's going to be used, but I would like to write one for a hobby and just understand it better. So yeah, it's gonna be good.
Yeah.
I'm getting tired of CRUD, man. I don't need. I want more. I want more than CRUD.
More CRUD.
Yeah, I want more than CRUD.
No, I did spend some time a couple months ago just sitting down and really looking at how, especially like IOU ring works in KQ a bit, and like how different like IOU ring and KQ are, and like how much KQ kind of can't do a lot of the stuff that IOU ring can do, but just like how kind of brilliant the idea of like, oh, we just have this kind of shared kernel user space buffer that's going on that makes it work like very, very efficiently. Because like the problem with event loop things is usually that the overhead of doing the system calls kind of kills a lot of the performance benefits you might get out of doing async, because you wind up doing just like a ton of system calls.
Yeah.
And like IOU ring is designed so you don't have to do nearly as many system calls, which is really nice.
I still like there's still a gap in my mind as to, I understand how data makes it from like the network interface into the kernel into the application, but I don't understand how that much data makes it in there. Because there's finite buffers for all of this stuff for the most part. Usually they're in like a what do they call it? A ring buffer. Thank you.
Ring buffers. Yeah.
Usually they're in a ring buffer, and these are finite data structures, and we're transferring gigabytes of information across things, maybe even more, depending on what you're doing. And like, it's just all happening so fast because it's easy to say, oh, I understand that I have 1024 bytes that came in on my NIC, and I put it in the buffer, and I notified epoll, and I told the program to read this thing. Great, but I need to do that many more times to transfer like multi gigabytes of data, and then TCP comes into it because it's not it's waiting for its ACKs to its packets and blah blah blah, and there's just so many layers to this. It's really really cool, and I'm excited to.
It's always hard to remember just how fast things are actually happening.
Yeah,
it's like there's like gigabytes and gigabytes, maybe in some cases getting up to the terabyte level of like data moving around. But it's also like we're operating at gigahertz, right? Yes. So there's like everything is happening so fast, it's hard for us to grasp onto. But yeah, just like even just the way that like you get data from a NIC to your application, it's like I don't think it's how people think it works, because it's like, yeah, you can't actually do 10 gig networking where the CPU is in control of everything, right? Because I think the model that people have is like, oh, well, like the CPU is running and you do a call to like read from the NIC, and then it'll do that reading, and then like maybe it's at the kernel level that it does all of the TCP stuff of the acknowledging and keeping track of the window and doing all of this stuff and sending the keep alives. But it turns out that like, no, because of the rate at which you're trying to send data, like the CPU would be spending like 80% of its time doing that.
Yep.
So the CPU is like, isn't actually involved. Like TCP offloading is like a pretty big thing that you have to do when you get to certainly 10 gig, but absolutely 100 gig or 400 or 800 gig networking. It's like, no, you have to have like a whole computer on the NIC that is handling all of the TCP stuff, and all like the kernel sees and all your application sees is like, here's some data, here's the stream of data. You don't have to worry about it. It's a stream of data from TCP. And this is the one for you from how you set up the socket.
The NIC's not even telling the kernel to write this data. It's doing direct writing. It's doing like, I recently learned more about IO MMU, which is just a memory management unit for IO.
Right.
And, so I had a whole conversation with one of my colleagues who actually I would like to bring on the podcast to talk in more depth about this stuff, because I don't operate this layer traditionally. Right. So it's nice to talk about these things. And I'm like, oh, so what you said is totally right, Kris, that CPUs couldn't keep up at these data rates. So the NIC has to write directly to some buffer in order to keep up with the data rates that are transferring. But you also want to keep those writes protected, and you don't want a NIC to be able to write into physical RAM just willy-nilly, right? You need to have some protections there. And then I started reading about IOMMU and understanding. I was like, damn, there's so much about computing I don't understand. And I do understand a lot at the same time. There's just so much more.
It's like fascinating because it's like, I think there's a model that so many people have of how computers work that's like from the 90s or from like the early 90s, where it's like, oh yeah, the CPU truly is central. It's the thing that's sitting there and coordinating between everything else. And like, if you want to access memory, you have to go through the CPU to do that. No matter what is trying to access memory, it has to go through the CPU. And then it was really the era when we got PCIe that all of a sudden all of that changed, because like the speeds, once we started getting fast, we figured out that the CPU became a big old bottleneck and people didn't want to do that. And PCIe is also set up, and PCI 2 is set up as a direct memory access system. So like a device is basically like writing into a space in memory, and people are just like, why do we have the CPU doing this for all of these peripheral devices you have attached? That's really silly. So they're like, well, we're going to not have the CPU do that. The CPU is going to be in charge of like the stuff you traditionally think a CPU is in charge of. And we'll just put another thing that is in charge of access to the memory, which is what the IOMMU is, because to the processor and in computing as a whole, for the most part, everything is just memory. So you write to some memory address that could be RAM, but that could also just be some device. Like it could be your graphics card, it could be your display, it could be your NIC. You're writing to these different address spaces, which we can do now much easier because we have 64-bit addressing. So there's like infinite amounts of space effectively for all of these different devices. And so that thing that sits at the center of your machine is actually the IOMMU. That's the thing that's running. Even the CPU has to go through the IOMMU to access memory. Which is really cool, but that's also how like the CPU can access, say, your PCIe devices, right? It goes through the IOMMU. The IOMMU is like, this space is mapped to this device. I'll go get that device. But that's also what makes things like Thunderbolt kind of terrifying, because Thunderbolt is literally just PCIe, right? And in the old days, you had PCIe, and like the only way you could access it is if you had like a card inside of a chassis. Right, that's the only way you could get access to this bus. And now we've just like made this bus be like attachable via a cable, which is like, okay, we get really good speeds out of that, and that's really cool, and it simplifies the whole system. But that like completely changes your threat risk. And then we also made the brilliant idea to also have that be the cable that charges your computer, which is like, oh, so now like any charger you plug into, or it's also the cable you use to connect to your monitor. So it's not like any monitor, any charger, any of that stuff is like also sort of sitting on this bus maybe that can access kind of anything. And there's a lot of rules, and we had a lot of hardware that gets developed and a lot of security measures that get developed to make sure that like you can't touch things you're not supposed to touch, so that your like charger can't just start reading random bits of your memory. But also you have to configure the IOMMU to stop that from happening. So when you first turn a device on, it's kind of like the wild, wild west. And then it kind of gets all configured as like, oh, okay, we got to lock all of this down. So it's like, like Thunderbolt is great, and charging over USB-C is great, and all of this stuff is really great, but it's kind of a nightmare for anybody that has to actually like build this low-level stuff and care about this and care about the security of it, because it doesn't work the way that most people think it works.
No, totally. And which is why I understand now that I have to authorize my Thunderbolt devices before they can connect and do things. I plugged my wife's MacBook here into my Thunderbolt monitor. I was testing something with it, and I was like, why is this not working? And then I unlocked the MacBook and I was like, allow accessory. And I was like, oh yeah, right, I have to authorize it, duh. And you're totally right though. It's a little PCIe plug that we have just around that can just direct. It's like it's like being hooked up. To give you the goods, man. Just inject it right to the veins. I got direct access. Just give you the goods. Oh, it's crazy. What we've done with computing.
To be honest, that was one of the things about like Lightning at the end of the day, which is kind of nice. Even though Lightning is like kind of old and they didn't really like develop it more for various reasons. But like in a Lightning connector, there's a little chip that has to have like some, basically like Apple has to allow you to manufacture a Lightning device. Yeah. So they have to like give you this chip that has this like information on it that does this handshake with the device. And that's to ensure that like this chip is legit and it's not trying to do things that are nefarious. But you just like don't have that at all with USB-C in general. So it's just kind of like when you plug that in, you're plugging something in like right directly into the heart of your computer, basically. And there is that little bit of time when it can like kind of do whatever it wants, which is super weird. It's like it's weird that like your monitor has access for a brief moment to like all of the RAM in your computer. It can just look at all of it. It can do whatever it wants, and all of the other devices. Right? It's crazy to me that like that's where we wound up with all of this. But
I'm gonna bring my colleague on, and we're gonna probably talk about this a little bit more because he has a lot of thoughts internally. I've seen some of the stuff he says, and he's like, why are we still stuck to these some of these old paradigms, and what can we do better? And I think there's a good conversation to be had around this. So I'd want to continue this in a big episode. Yeah.
So we can also talk about SATA and SCSI.
Yeah, all of it. Literally all of it.
Oh my God.
There's so much there to unpack.
But you know, speaking of your colleagues, Oxide had a pretty big announcement today, the day we're recording. But
the date of recording today, July 30th, 2025. You know, that wasn't inferred. Yeah, we announced our Series B fundraising, 100 million. Which is great. I mean, obviously every company needs capital to survive, especially startups, because that's the whole point of a startup is you are generally VC funded to the point where you can be self-reliant on your revenue and pay your VCs back and blah, 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 blah. I don't want to get into the whole capitalism, VC funding, bootstrapping. That's the whole topic of conversation for another day. You know, like, go try to start a hardware company without VC funding and then come talk to me because it's very difficult to do that.
Good luck with that.
Yeah. But we announced that and it was great. Good energy today. Everyone's really excited. It really does give you a breath of fresh air. Obviously, we as employees have known about this for, you know, weeks or months now or however long it's been. But super happy to the embargo, everything's lifted and now we can all talk about it. And it's good for a couple reasons. One, obviously as an employee, having money means we get paid, right? So every startup, I don't think we as an industry talk about this enough, but every startup is a risk for both the company to hire you and for you to join, because you don't have infinite runway of cash or capital. Like there's a finite amount of time to where if by this date we don't have more money, we have to close, right?
Right.
And you know, so the funding gives us at Oxide a nice breath of fresh air for our employees to be like, yeah, we're here for another couple of years or whatever it may be, right? And that's huge. And it gives our customers the confidence that we're going to be around as well, because now there's capital behind us. We can make the purchases we need to make. We can do the development we need to do. We can just business as usual. And it's really, really nice. And then I read the Hacker News post and then my day was ruined.
Oh, God. Wait, what were they saying on Hacker? How could they say something negative? I don't get what negative things they could say.
I don't want to draw too much attention to the trolls or whatever, but man, you post anything on Hacker News and the trolls just come out. Everything from our compensation structure, right? Oxide is famously like pay everyone the same base salary. Obviously, equity is not the same everywhere because how could I get the same equity as Brian Cantrell? Like for real. Like let's just think about that, right?
Yeah.
So we had some people just attacking from that angle, like, tell us more about your compensation. Why don't you have equity fair across everyone? What are you doing? Blah, blah, blah. And we're just like, dude, go away. Like your company doesn't pay you and your colleagues the same. Why are you arguing with us? So we had that angle. And then other people were like, you know, what does Oxide do? Are they doing anything? Or they're just a hardware company, right? What are they possibly doing? And it's like, dude, we make our own stuff. What do you mean?
That's crazy.
Yeah, it is wild. And then there's I don't want to overshadow the negative with the positive because there's an overwhelming amount of positivity there. Like, hey, and I'm really bullish on you guys. Great team here. Good job. Congratulations. A lot of that too. But the bigger threads are definitely the negative ones.
Yeah. That's what people always want to get they want to get in the mud. They're like, come get in the mud with me. And I just took a shower. I don't really want to like do mud wrestling.
You're a little stinky right now. I'm okay, actually.
Yeah, I'm good. I'm good. Thanks.
But no, really exciting times. And then we got onto the topic of like, I obviously don't want to break about Oxide, but I do want to talk a little bit about maybe just funding in general and fundraising. Obviously, I'm not at the level where I'm signing these deals or whatever. That's more the Brian Cantrell, Steve Tuck side. But it's funny because other companies are raising money too. Like Anthropic is announcing their potential to start raising. Ramp is announced they're raising stuff. We've announced our raising stuff. Like, and then you look at the numbers though, it's funny. Oxide sitting here like, yeah, raise 100 million, Series B, great. Ramp is like, we raised 500 million. And we're like, wait a minute, hold up. That's a lot of, that was another big thing that Hacker News and co were asking us, like, what do we possibly use $100 million for? That's a lot of money. Hardware is expensive. Manufacturing is expensive.
Yeah.
Like, it costs money to buy the components that we put in the Oxide rack and to assemble it. And then you look at some of these other companies, like Anthropic's looking for $5 billion of raise or whatever whatever it said in the news sources.
Crazy.
And I'm just like, what are they using the money for? Like, don't look at us. We're just at this little pitty $100 million. These people are 500 plus. Yeah, crazy.
Yeah,
you know?
like.
Not to say they don't need it, but
like, like Oxide, I felt like I was like $100 million, and I was just kind of like, part of me was like, wow, that feels like a little low. Like, I feel like a hardware company would like need more money, but like, then I read the blog post. It was like, this is more than we've raised combined so far. So I'm like, okay, like putting that in perspective, it's like, okay, you can actually, you're running this company lean and well, so you don't need like tons of capital, and I can kind of see like why Ramp might need more capital as like, because that's like the financial company, right? Ramp is the expenses financing credit business cards. So I can see why they would also like having a lot more capital could be useful to them. They could also like, they could start spinning up things like lending arms and things like that, which would be helpful in growing their business. So like $500 million, I'm like, okay, but like $5 billion for an AI company, I'm like, what?
No, I know. We were doing some of the math internally when we were talking about some of this stuff, and Ramp has, I think, like 1,200 employees, right? So $500 million, 1,200 employees. If every employee got paid $200K there, you're looking at $240 million in annual salary, just salary for Ramp. And I'm like, oh, okay, that's how that $500 million goes away quickly. I get it. Yeah. Do I know if they need all 1,200 people or not? I don't know, right? I don't know how they run the business.
All 1,200 people are obviously not making a quarter mil, and they have revenue, so it's not like
exactly. But yeah, the $5 billion just sounds so like it's like $5 billion on $170+ billion valuation, and I'm just like, are we just making up numbers now? Like, how is this accurately determined? Because what? Do you understand the words that are coming out of your mouth? Like, that's a lot of money.
Crazy. Yeah, there's some things that like a hardware company makes sense to me as a startup, because there is like so much upfront cost to build, especially with like what Oxide wants to do with hardware, to building all of that out, right? You have to take the years of R&D of doing the hardware development and the software development together, and it's going to take years to develop and push out a product, but then you are at the point where we're pushing out a product now, and then you're like, okay, there's even more stuff that we need to build, so we need even more money to get even more runway. But for some of these like more like purely software companies, I'm like, this is such an absurd amount of money, and I know it's an absurd amount of money simply because we probably pay software people way too much. And no, we definitely pay software people way too much for how little output we get from all of them.
No, true.
Right? Like if you think of your standard project at a company where you might have like 20 or 30 people working on it together, and it lasts like 3 years, and you're like, okay, well, you just spent several $1 million to build something that's not even going to last the term of a presidency in the United States. Like that's just crazy to me that we spend so much money doing that. And it's like, it's not even that like you plan to get rid of it in 3 years. It's that 3 years down the road, you're like, wow, this thing sucks so much, we have to rebuild it. And it's like, this is just the kind of common background noise of our industry, is that we build stuff and then we immediately want to replace it. And it's like, that's why everything's so expensive.
Yeah. I wish more companies were transparent about their books and finances, because I understand if these AI companies, they're building their own data centers and putting GPUs in it. I get that that's expensive. I really do. I understand. But the software companies who are like making use of some of these GPUs, or maybe they're not even in the GPU market and they're just strictly software. Like, what are you spending money on? Like I really just want to see the books of some of these companies and understand, where are you spending your money? Where is your revenue coming from? And just really better understand the number that they're raising. you know, because internally at Oxide, we do have the benefit of transparency for us. Like we have our finance team posts our numbers like weekly internally. So we all are seeing the high level numbers of like our run rate and where we are in the cash in the bank and all that stuff, which is amazing, right? Because they don't have to do that. But like, I can't imagine. Oh yeah, we just got 5 billion today. Like, you know, brush it off my shoulder so nonchalantly. Like, yeah, you got 5 billion today. But
I mean, what's the
expense?
The number of finance people you need to figure out how to properly manage that money and then actually manage that money.
Yeah,
it's just like you need a whole department of people just to do that. Like I remember Nebula, the streaming service, they did some videos about like how Nebula works, and they're one of the guys. I guess he's like sort of like, I think he's just like one of the very, very early people. I don't think he's a founder, but the guy that does real engineering and real science. He was like, yeah, you know, people think that the most expensive part of operating a streaming platform is like the streaming part of like delivering the video to people. But he's like, no, it turns out in the modern day, that's actually extremely cheap. Like, that's not expensive at all. The thing that's expensive is hiring all of the people you need to hire to build all of the apps and to build all of the infrastructure behind the scenes to actually run it, because all of those people are very expensive and you need just a lot of them for so many different platforms. It's like, yeah, streaming is not that expensive, especially now that we're in the world of like Fastly and Cloudflare, where like it's bordering on free to stream, to like set up like a streaming system of some kind. Right. It's like there's like no egress costs for so much of what they do, right? Yep. So it's like, okay, well, the thing you're paying for is like API calls and some other stuff. So it's like, no, like the cost for so much of tech usually lies within the people cost of hiring all of the very expensive software people and program and project managers and all of that stuff, and all the VPs and all of the managerial structure that you have, which is probably no, it's definitely never set up correctly to make a tech company run well.
Totally. I know we try to keep these a little shorter, so I won't go on too long here.
This one can be a little longer.
It's fine. We like to think of ourselves as like this artisan craftsman type in the software world, but we're not. We're basically assembly line workers in a sense, right? Like the vast majority of us, we're not creating handcrafted artisanal fine furniture here. We're assembling chairs, you know, and that's okay. I'm not saying that in a bad way. I'm not saying like, oh, our jobs suck, we should feel bad. It's just that we need the work, right? So many technology has become a commodity for every business. It's almost a requirement for every business that everybody needs the chair built. You know what I mean? Like everybody needs a chair. Right. Not everybody needs a very fine chair. They need a chair. And that's really what we're doing, right? And there are great people in our industry that can make really fine chairs and really good software, whatever the analogy we want to use. But the vast majority of us really are doing the commodity stuff, and that's okay. It's just, since that stuff is so valuable to the businesses, we get paid, you know, a lot of money for it. And sometimes the value is really not there. Like I know people that get paid way more than they should for the value that they're giving.
Yeah.
And, you know, it sucks, but that's just the way of the world. And that could be said for any profession. But yeah, I try to make sure that like I understand that in my role. Like I'm not going to sit here and look at myself saying I'm the only one that can do what I do. No, anyone can do what I do. I can do what you do too. But it's just a matter of finding your value and marketing yourself that way, because that's what's going to get you paid and continue to get you paid. It's just, this whole like, we're so special, we're unicorns, and we should be paid $100 million. No, we're not. No, we're not, dude. If in 3 weeks someone can learn what you can do, then how special are you really? You know?
Yeah. I think it's part of the problem. I think with our industry is that people like we should be an industry of artisans, right? We should be an industry of people that are doing, because we're doing a craft. We are like, even though every company is sort of building the same thing, that thing is different in each company. It's like, that's where we aren't like assembly line workers, right? We're not building like 10,000 cars. We're not bottling a million bottles of ketchup. We're not doing things that are repetitive. Like anything that we build, this is like the first time we have built it in this context. So we're building something that is not the same, but there's this intense pressure as an industry to pretend that almost all of it is the same, which I've always found to be very, very silly. Like that the whole argument people have of like focus on the thing that is different, that you can do, and everything else you should just try to like find somebody else to do it for you. I've always found that to be kind of silly, because I think it just mistakes what it is that we are all doing at the end of the day, and how much it matters that you understand how the whole thing works. Like people, I mean, that's what you were saying, like people don't understand how the stack works. They don't understand how computers work. And they don't even understand how like the top layer of their stack works. The number of people that are like, you're not a front end developer, you're just a React developer, or the people that are just Rails engineers, or the people that are just like, you know how to do your one thing, and if you have to go outside that thing, that's going to be a big problem for you. And I think there was a world where that was a useful thing when a lot of the frameworks, a lot of the libraries, a lot of those things that were like Rails or React and all of that were like doing something that it wasn't feasible to really have everybody do, because there was so much monotonous work involved in making the base platform function well.
Yep.
But we're not in that world anymore. We're in the world where most of our base platforms actually work really well. And they put a lot of work into the developer experience to make it so they're usable, especially in the browser space, but also in the backend space, right? Like that's the thing with Go for so long, is that people are like, well, what web framework do I use? It's like, you don't need one. You have the standard library. Just go use that. Yeah. And it's like, it does enough for you that you don't have to do monotonous stuff, but you have to do the stuff that's specific and special to you. And that's also how we start moving forward. Because if everybody is using the same framework or the same set of frameworks, then those frameworks, like it gets you in this bad cycle where those frameworks have to be trying to appeal to the mass audience, and the mass audience wants a specific thing out of that framework. So then the frameworks don't really move at the same speed that they would be able to move if they were not trying to appeal to such a large group of people.
Totally. It's funny too. We in the software space tend to look down on people that are in the trade space, and by trade I mean like plumber, electrician, contractor, think people that kind of generally work with their hands. Right. But we're so alike to them in many ways. And it's kind of odd that people look down on them, because electrician, you call them to come to your house, and yeah, they are doing the same repetitive task, and I'll air quotes that, they're running electricity, installing outlets, running line, fixing up your panel. They're doing repetitive work, but they're doing it in a different context each time. Your panel might be located in a really hard to reach place, or you might be using old wire or new wire or this, or wired differently or incorrectly. And they're going into an unknown space in a different context to try to do the same kind of job, but in a different context. And so there's that aspect of it. And we do that as software people too, right? We go to another job and we're still writing CRUD apps in a different context. Oh, this one's Ruby on Rails, this one's Go, this one's Rust. Doesn't matter. It's same work, different context, and that's where we can apply our skills. But then also the craft doesn't die. You can hire an electrician to go rewire your electrical panel or whatever they do, and you can hire two electricians, and one of them can do the job and it does it okay, and the work just looks like garbage, sloppy wiring, didn't staple the cables down correctly, didn't tighten things right, didn't cut them to length. It's just ugly. And then you have one that did the job, but did it well, and with a high degree of craftsmanship, where things are neat, it's labeled, it's cut to length, everything's pretty. You look at that and be like, wow, whoever worked on that knew what they were doing and cared what they were doing.
Yeah.
And in tech, we have so much of the former, where people are just like, yeah, I wrote a CRUD service, look at this. It's like, dude, your code is garbage. You didn't even review your code. You just shipped it. And I've worked with people like that, where I looked at their code, I'm like, dude, this is disgusting. And yes, it works. And I'm not saying disgusting in the funny, clever sense, where it's like, oh, the Python one-liner, like how crazy is... No, I'm not saying that. I'm saying it's actually gross. It's like I'm looking at garbage.
Yeah.
But the garbage is functional. And I'm like, you could have taken another 20 minutes and cleaned this up, and it would have been like very presentable. And you didn't. And what does that say about you? And that frustrates me.
Yeah, I think one of the things that I think about a lot is how we, as an industry, as like what we do, we sit in this weird space it is a lot like the trades. It's a lot like what electricians and carpenters, especially carpenters, what they do, but we're also so much like what artists do, like, the musicians, the painters, all of that, right? we're so much like what those people do. And I don't think that we have really taken a steak on the grill, bro. What? Anyway. Sorry, viewer. Matt has to go soon to cook some steak. In this
Damn it,
heat,
Kris, I used the chat for a reason.
In this heat, you're crazy.
No, I know. I know. But it's what wife and I want. So
fair.
I'm bound by things.
But no, like it's we are so much like the trades and what we're doing, where we kind of like going into a space and like we're trying to figure out the first time, but we're also like what we do is so much like what artists do, yet we aren't really taking advantage of either of the things that allow those people to do what they do well, right? Like in the trades, you have to apprentice, right? You have to go train under some sort of, master electrician or a master plumber or whoever that's going to like teach you all the things and show you and watch over you. And that's how you gain the practice and the skill over time, is by working with these people for a long period of time, so that you now understand the thing, so that you can now go develop the thing. And with the arts, you tend to do that practicing, but on your own. Yeah. So you do it in a more self-referential way. So you're like, if you're a musician, you spend most of your time sitting down and practicing on your own. If you're a painter or something, that you're usually painting on your own. So usually the whole job is to do that on your own, but you might train under somebody else, or be inspired by other people and train with them. And same thing for like so many of the arts work like that. And I think as an industry, we'd benefit a lot from going down the path of like practicing and doing that artistry, because it doesn't require the type of system that you have to have all of these master people that can do it and train you and have apprenticeships. That's a lot of infrastructure. And I feel like we as an industry are kind of trying to go that method. Like we've definitely set up our internal structures to be that way. That's why we have all of these ridiculous levels where you have junior engineers and intermediate engineers and senior engineers and staff and staff plus and principal. We have all of these things that are kind of like reaching for the idea of like apprenticeship. Like I think we like to see junior engineers as apprentices, but we don't treat them like apprentices, right? That's not how we actually go about using those people. But I also don't think that's an effective strategy for us. I think at the end of the day, we are more like people that need to sit down and do a lot of practice. And given how much we fuck up software, I think that we should be actually sitting down and doing more practice, and more companies should be aware that most of the time you're spending paying these people is not to build the thing, it's to learn and see enough iterations of things to build it, right? If you're in like a symphony or an orchestra, right, you will get out there and play, but you're also expected to do all of the practice, so like learn all the pieces and get really good at them, so that when you go and perform, your performances are flawless. They're great. They're an amazing experience for people. Same thing in like the theater, where you have all of this time before you start a run of a show, where you're just doing all this practicing and dry runs and rehearsals, and you start to get to the place where you're actually going to do the real thing. We as an industry just don't want to accept the fact that we should probably build stuff and like rapidly throw it away a few times before we go build the final thing that we're actually going to ship. Yep. Like that feels like it's like such an anathema to us. It feels like, but why would I waste all of this effort? And it's like, but it's not wasting. You're learning. And in the idea of agile, like you should be trying to learn as rapidly as you can, so that when you do need to go build the thing, you can actually build the thing. You can actually nail that performance.
I wish we like remembered ourselves as babies more than we do. Like the difficulty of walking for the first time, and how many times we had to fall and do other things to walk. And then now we just take it for granted. It's the same thing here in the tech. Like you're supposed to be building and getting things out there and iterating and learning. And you have to fail. You have to succeed. You have to try again. You have to experiment in order to grow. And then when you can build the final thing, it's like, it's actually good and you're building the right thing. And I saw this social media post the other day from some Google product person, whatever it was. Like at Google, we're transitioning from a writing culture to a building culture. Like in the age of LLMs and vibe coding, you can just build your way. You should be building things and not writing, essentially. And I'm like, well, actually, you're just choosing where to optimize your results. You're trying to optimize for results earlier in the stage, like day zero results, versus building something maintainable. And both are valuable. Don't get me wrong. I'm not going to sit here and say building only sucks and writing only sucks. They're both valuable. But you can't sit here and post something on social media like, yeah, we're moving away from writing to building. And it's like, well, but no. Like that's like saying I'm going to go build a house with no plans. I'm not going to write blueprints down. I'm not going to write specs down, nothing. I'm not going to write anything down. I'm actually just going to lay some bricks and we'll figure it out. Like, that sounds silly. You know what I mean? Especially when you're building for someone who's going to live there. Maybe if you're just experimenting and learning, fine. That sounds great and dandy. Lay some bricks out. Who cares? But if there's an end user that needs to be involved in that and going to use the product, you can't just build your way. You have to write things down and critically think about it. And I quote posted that post or whatever it was, and I was just like, I don't have time to get into this tonight, but I have thoughts.
Well, maybe we should do a podcast episode about that, because I had thoughts about that as well.
Yeah,
especially with the big tech companies too, because
I'm just getting a little upset seeing people throw away their beautiful like brain in the spirit of, oh, the LLM and vibe coding is going to do this for me. It's like, no, your brain matters still, and you should exercise it and challenge it, and you'll be better off even with the tools that you have. Like, even with the LLM and vibe coding, you should still exercise your brain. And it scares me that people are not.
Yeah, I mean, it's kind of like how, I mean, it really does tell you how much people don't see themselves as artists, because like the artists out there, I mean, at first I think a lot of people were afraid of AI, and then they saw that AI just produces slop, and they're like, wait, like, people don't want slop. Like, sure, it can produce things that look, that can kind of emulate what really great artists can do, but like, it can only emulate things that it's seen before, and great artists really try and always do things new. They don't want to just recycle things. That's when they get old and tired, and it's just kind of like, I don't know if I like this artist anymore. It's like great musicians, like, they're always coming up with something new. They're always kind of do new, like, bring something new to their style. Like, a lot of the recent artists that have come back, like, there was this era in the early 2010s, like late aughts, early 10s, of like Kesha and Lady Gaga and Katy Perry and all these artists that came up, and like Kesha and Gaga are like really back in the mainstream again, and their music feels like it did in the aughts, but it's not a carbon copy of it. It's not just a clone of what that was. It is a new take for the new era on what they were doing before. And that, I don't think, would have come about with just like using AI to do something, or someone trying to replicate their style. You have to understand like what's the underlying thing you're trying to do. And I think as software engineers, we need to take that embodiment and really have our own style that develops in all of this, you know, a better understanding of what we're doing as an art, instead of just being a means to an end at the end of the day. Yeah.
I'm not gonna trigger you to go on to the next topic, so I'm being quiet. No, because we could stay here talking forever, and I love that. But you know, I also like, I want to do that sometimes. There's times where I just want to stay and talk and just keep going on these topics, but also I know our listeners are probably like, hey, I need bite-sized things to listen to.
Yeah, this is true. Which
so
we're working on.
It. Yeah, we are working on it. I know, listener, viewer, I know that we go into tangents. I know we take long to talk about things. I know. We know our problems. We understand. It's just being here and doing it live is different. You know, there's just so many things you want to talk about, and you don't always have the time. And then you look up at the time, like, damn, how? And then if you say too rigid and you go like, Kris, sorry, you're 3 minutes up, sir. Please go to the next topic. Like, that sounds silly too. So yeah, no, it's all, you look at the first few minutes and you're like, wow, we've only been talking for 3 minutes, and all of a sudden it's at 35 and you're like, wait, what happened? Yeah, exactly.
It flies. But yeah, I think we can close it out here. Thank you, listener, viewer, for joining us for this. I think this is the first time we've done Break with just the two of us. So kind of at the heart of what Break was meant to be, which is just me and Matt chatting about who knows what. So yeah, what did you think about this? Did you enjoy this? Should we do more episodes that are just kind of me and Matt chatting about what's going on in the world? Let us know on social media. And as always, please go listen to the main podcast as well. We put a lot of work into making Fallthrough great. I know you can't see our faces yet, but those will be coming soon too. Yeah, and with that, see you next time.
Bye.
Thank you once again, listener, for listening, or I guess viewer, because you can see me doing this right now, for watching. This episode of Break featured Kris Brandow and Matthew Sanabria. Break is a Fallthrough Media production and is produced by Kris Brandow, and our beats are by Breakmaster Cylinder. And then there's traffic outside. Hello. Okay, let's do this. Okay, I'm just gonna record the outro right now so I can go quick.
Perfect.